Hello and welcome to this lesson on exothermic and endothermic reactions. In today's lesson, we will, firstly, understand the difference between exothermic and endothermic reactions. We will then learn to relate this to the principle of the conservation of energy. So far, you've become familiar with calculating energy changes. This means you understand how to determine the energy absorbed or released during chemical reactions. Building on this foundation, today's lesson will advance our chemical understanding by illuminating how these energy changes can be categorized. By grasping this concept, you will deepen your insights into why certain reactions release energy while others absorb it, furthering your overall comprehension of energy transformations in chemistry. Let's delve into understanding exothermic and endothermic reactions and how they relate to the making and breaking of bonds in chemical reactions. Firstly, exothermic reactions release energy into the surroundings. Think about the campfire. The chemical reaction of burning wood releases heat, which you feel as warmth. In this process, energy is transferred to the environment. In contrast, endothermic reactions absorb energy from the surroundings. Imagine an ice pack used for injuries. When you break the pack, an endothermic reaction occurs, absorbing heat from the surroundings, including your skin. This transfer of heat away from your skin is what makes the pack feel cold. Now, let's explore why these energy changes occur, focusing on bond breaking and bond formation. In our previous lesson, we established that bond breaking requires energy, whereas bond formation releases energy. For an exothermic reaction, the energy released from forming new bonds is greater than the energy required to break the initial bonds. This excess energy is released into the surroundings, making delta H, what we call the change in enthalpy, negative. For example, when natural gas, methane burns, the energy released from the formation of water and carbon dioxide molecules is greater than the energy needed to break the bonds in methane and oxygen molecules. In an endothermic reaction, more energy is required to break the initial bonds than is released when new bonds are formed. Therefore, energy is absorbed from the surroundings, making the entropy change positive. A prime example is the process of photosynthesis in plants, where energy from sunlight is absorbed to break the bonds in carbon dioxide and water, forming glucose and oxygen. The law of conservation of energy is fundamental in chemistry and physics. This principle states that energy cannot be created or destroyed. It can only be transferred or converted from one form to another. This means that in any chemical reaction, the total amount of energy remains constant. If some energy appears to be lost in the reaction, it must have been transferred to the surroundings, and vice versa. In an exothermic reaction, energy is released from the system into the surroundings. This release of energy usually manifests as heat, causing the temperature of the surroundings to increase. Conversely, an endothermic reaction absorbs energy from the surroundings into the system. This energy absorption typically results in a temperature decrease of the surroundings. In today's lesson, we delved into the differences between exothermic and endothermic reactions and learned about the conservation of energy. We explored that in any chemical reaction, breaking bonds in the reactants requires energy, while forming new bonds in the products releases energy. For exothermic reactions, more energy is released during bond formation than is absorbed during bond breaking, whereas for endothermic reactions, more energy is absorbed to break the initial bonds than is released when new bonds form. This knowledge helps us comprehend the energy dynamics in chemical processes and their effects on our everyday experiences with heat and cold. We also learned about the law of conservation of energy, where energy cannot be created or destroyed, only transferred or converted from one form to another.